Hello, I'm Paul Verholic, and I've worked on a project for gesture communication using the Nintendo Wiimotes. So I want to give a brief demonstration of that. Specifically, we're looking at computer-mediated gesture recognition with one- and two-handed gestures with various output mechanisms. So we can have animation as an output, sound as an output, and now even a haptic belt. This tactile belt was from Lieutenant Colonel James Merlot of the U.S. Army. We are running a study here to actually do testing of this device as an output mechanism with gestures and as an input mechanism at West Point. So if we look up on the screen here, just a brief technical description, we've got Bluetooth connections to both of the Nintendo Wiimotes and the haptic belt. If we look at that data, this is just a traditional Bluetooth stuff. There's nothing special going on here. For the Nintendo Wii connectivity, we're using an API from Brian Peak, Microsoft guy that does coding for fun.com. If you pull up the Wiimote gesture training stuff. All right, so if we look at this application, we've got a little bit of visualization of the three axes that the Wiimotes operate on. So the right-hand gestures, left-hand gestures. That all starts off as simply XYZ accelerometer data. Those values run from 4 to -4, and what we do is we extract values out of that. We extract features out of that data that can identify a particular gesture. If you look on the screen here, we've got a series of gestures that we've already identified for this particular application, but there's nothing hard-coded about this. We've said we've got a gesture for attention, start engines, halt, increase speed, stop, disregard right, which I'm going to talk about here in a second, and then mount up. If we look at the left-hand gestures, we've got disregard left, and disregard left and disregard right combinations, okay, are actually combined into a single combined gesture called disregard. So if we go to the classification tab now, we're going to do a little bit of classification to see how accurate this system is. So I'm going to put the haptic belt on. Stop engines. Okay. So that belt is vibrating. It's got 8 tactors that are arranged around your belt in 45-degree increments. And it's not like a pager motor. This you're not going to fail to miss these tactors when they go off. So if we look at some simple gestures, attention. So that's attention. We've got an animation map to that, a sound map to that, and vibration map to that. Attention. So that vibration is in a particular sequence that allows us to do. We can train an individual that says, yes, this sequence of vibrations in this pattern maps to the attention gesture, or halt, or increase speed, or mount up. Two-handed gestures we can do disregard. So we can do both one- and two-handed gestures. We have a few more in this particular demonstration. Start engines, and this is actually a circular pattern that's going around my waist, and then stop engines is the opposite direction. So this is just a very brief demonstration of what could be a very powerful application for not just for the military. This is, of course, just a military demonstration, but you could even consider people who are speech or hearing impaired having a speaker worn on their shoulder, or we do hand gestures for people who don't understand sign language. We could convert that to actual speech. And that concludes our demonstration. Thank you.